So we were discussing about Reserpine, right? So in this class, let us determine the structure, right, or structure elucidation of this Reserpic acid. Reserpic acid. Because I told, if we determine the structure of this Reserpic acid, we can easily tell the structure of this Reserpine, which we have discussed in last class, right? So let us not waste time in discussing the same thing, right? So structure elucidation of Reserpic acid, the scientist found out that its molecular formula to be C22H28N2O5. So it has got 5 molecules of O, right? Initially it is the molecular formula of this Reserpine and it is O9, now it is O5. And also they found out that this Reserpine is there, right? So let us do few things. So from titration experiment, titration means acid base reaction they did and they got that this Reserpic acid has got one equivalent of acid group, means COH group. So one equivalent from titration experiment. And also reaction with HI. I told whenever OCH3 group is there, right? So there will be formation of CS3I, methyl iodide. From how many equivalent of methyl iodide it has formed, from that we can see how many OCH3 group is there within this Reserpic acid. They found out that 2 molecule of CH3I formation has happened. Means this Reserpine has got 2 equivalent of OCH3 within the same Reserpic, right? So now Reserpic acid. So its formula is C22H28N2O5, right? And also from titration they found out that one equivalent of COH. And also I told in the last class there will be COOH and there will be alcohol, right? So there will be one equivalent of OH. This we have seen it because acid base hydrolysis, since it will be in ester form, this Reserpine will be in ester form. So when we do hydrolysis, we will get Reserpic acid along with two products, right? So it has got COH and OH. So one equivalent of COH and one equivalent of OH. And also from this HI reaction, we found out that this Reserpic acid has got two equivalent of OCH3 group, right? So these were the conclusions they came up with, right? So how many oxygen they accounted? So 2 oxygen they accounted as OCH3 and one equivalent of OCOH, and there is one equivalent of OH, So now you check 1, 2, 3, 4 and 2 equivalent means 5. So they accounted for 5 molecules of oxygen, right? So from acid 2 and one equivalent of alcohol 1 and 2 equivalent of OCH3 means 2. 2 plus 1 3, 3 plus 2 it is 5, right? So from this they found out that it may contain this thing. And also few more experiment let me call, that is heating. Next they did was heating reaction. So what they did was this Reserpic acid, they took this Reserpic acid and they heated. When they heated, they found out that there was formation of ester, but we don't call it as ester because that ester was cyclic ester, and this will be called as cyclic esters are called as lactone, not ester. We won't call it as simply ester. Cyclic esters are called as lactone. It means that, see, the COH group and OH, which were one equivalent, both are present on same ring, right? So let us assume it is like this. Both are present on same ring, OH and COOH. When we heat, they do the reaction. And we know that we never write cyclohexane like this. Cyclohexane will be written in chair form. If both OH and COOH are on equatorial position, then if we heat, there may not be reaction because the distance is more. But while heating, they come like from equatorial, they come into axial. Here it is COOH and here we have OH. It was equatorial, but at thermodynamic condition, that is at heating condition, they come it as axial and axial. So now you can see 1, 2, 3, 4, 5. 5 membered ring formation can be very easily done. So this comes out, and this OH minus will move as OH minus, and this H plus whenever there is loss of water molecule while heating, condensation kind of reaction, and there was formation of cyclic ester CO, right, and it is O. This is the reaction, right? So what is this ester? You know, COO. Here it is R, and here it will be R dash. So it is ester. If the same ester present on a ring like this, so this is the same ester COO which is present on a ring, and this is forming 5-membered ring, 1 2 3 4 5, right? So this kind of esters we call it as lactone, and this they did lactone formation. So at thermodynamic condition, 5-membered lactone will be easily formed. So these are thermodynamically very stable product, right? So these are very formed very easily. If we had IR spectroscopy, we can tell 5-membered lactone means it will be around 1780 per centimeter, right? So when we discuss this IR spectroscopy, there you will get it, right? So this will be the value if we see this, right? So when they did this heating experiment, they used to get this lactone. So what conclusions they got from this reaction? The thing is, they got that the both COH group and this alcohol group both are present on same ring, and also second conclusion, and the stereochemistry of this COH group and OH group are same, because see, unless this stereochemistry is both are axial means here it is also up and this is also up, right? Unless both are up, this reaction may not happen. If one is up, one is at axial, one is at equatorial. For example, let me write it here, right? If one was axial, this alcohol is axial and this acid group is equatorial, this reaction may not happen because distance is more. So if we heat, we may not get lactone, right? So since both are axial, so both are in same stereochemistry, both are up, it is also up, it is also up, so same stereochemistry. What conclusions? Both acid group and alcohol group both are on same ring, first conclusion. Second conclusion is that both acid and alcohol have got same stereochemistry, because of which when we heat we will get this lactone by eliminating this water molecule. And the reaction, you know, these are the basic reactions, right? So this was the conclusion they got from heating experiment, right? So let me rub all those things so that now we can easily give the structure of this reserpic acid. Once we give the structure of reserpic acid, further we can tell the structure of reserpine, right? So let me give. So the next conclusion was lactone. So from here two conclusions we got. Let me not write here because I have told both are present on same ring and same stereochemistry, right? These conclusions they got, and also they told for 5 oxygen, 2 3 4 5, right? 5 oxygen. So from this they got all those things, right? And also this lactone formation, one more proof they gave for this lactone formation. Not only heating, what they did, they took this reserpic acid. To this, if they heated, they got lactone, right? So to give evidence, few more reactions they did. The one more reaction was KOH. They added this strong base KOH pellet and they heated it. So KOH fusion reaction they did. Again they got this thing. This thing they got. Within a ring, there was OH, there was COOH, and one more COH they got here, right? So they concluded that this lactone formation was because of these two reactions, acid and alcohol, which is present on a same ring to form cyclic ester, that is nothing but a lactone. So these were the two reactions through which they concluded that both OH and COH group, here OH and COH group are present on same ring and they have got same stereochemistry, because unless same stereochemistry, this condensation reaction may not be possible to form this lactone, right? So These were the conclusions they got from these reactions, right? So with all these reactions we cannot tell the structure, so they want some few more strong evidence to tell the structure of this reserpine. So next experiments were oxidation experiments. So these experiments are there, right? So this helped to tell the pakka or the exact structure of this reserpic acid. Further from this we can tell the structure of reserpine, right? So oxidation experiment. So what they did, they took this reserpic acid, Ra means reserpic acid now. So reserpic acid they took, to that they added this KMnO4 oxidizing agent, right? So they got this product. Can you tell the name of it? It is very easy. Acid here OH and here NH, right? And it is CO and it is again OH, and then OCH3. One of they determined that this reserpic acid has got two equivalent of OCH3, in which one equivalent was here only, right? When they did this KMnO4 oxidation, there was breaking of some bonds and they got this product, and the name of this product is, see, it is numbered like this: 1 2 3 4 4-methoxy, right? 4-methoxy N there is oxalic acid, right? So it is called N-oxyl, and this is anthranylic acid, anthranylic or anthraline acid, just to check, right? So they got this product and they confirmed this product by synthesizing it within lab. So what they did, they took this compound, that is acid group, and there is aniline and it is aromatic benzene ring, so it is aniline we called, and here at this position OCH3, that is at 4th position only they take 1 2 3 4, right? So this is nothing but anthranylic acid, 4-methoxy anthranylic acid at right? So this product they took, to that they added oxalic acid. Oxalic acid means COOH and COOH, right? So this is oxalic acid. So the reaction was simple. So this OH removed as water molecule and they got this N-oxyl to this nitrogen. This bond was formation, nitrogen carbon bond formation, and they got this N-oxyl, this compound, right? So they synthesized this compound within lab, so that to tell whether they are getting same product or not. After this reserpic acid KMnO4 oxidation, they got this product. So they synthesized it to tell the structure of it, whether this is possible or not, right? So from the synthesis they got that it may have this product. So they can tell the structure of this now reserpic acid, right? Because it has got this kind of ring, they can tell it easily. But what they did, they took this compound, see, here also aromatic, this is also aromatic, and here it was nitrogen, and the name of this compound is beta carboline. And they took this compound, they did this KMnO4 experiment, and they got same kind of result here. So what they concluded, so this reserpic acid has this kind of structure, because when they did this KMnO4 oxidation, the bond was broken like this. See, this N is there, the bond was broken somewhat like this. Just you do like this, first you break like this, so that you will get this thing. I hope you are getting it. So this pi bond I am going to break. So here I will get COO, and here NH, and again here COO, right? And other things, let me keep them as it is, right? Here COO means here I have got nitrogen here like this, alright? So this compound they have. So this KMnO4 at heating condition, it is a strong oxidizing agent. If I remove like this, see, if I cut this compound like this, so while heating, if I cut it like this, I will get this compound. See, Here OCH3 is there as it is. Sorry, I should have taken this OCH3, but here beta carbon line, if they take, they'll get this product. See, benzene ring here. Now here they got COOH, as this bond is broken by this KMnO4, and here they got NHCO, this bond is broken, again COOH, and these 1 2 and this nitrogen, they went off like gases, they went out, right? So they got this structure which was same as this structure. See, NH2, see this acid group NH2, only thing is this OCH3 is not there. That they told that this OCH3 is there at this position, 4 position. So this reserpine acid, sorry, reserpic acid has got this beta carbonyl structure by this experiments. So when this reserpic acid came in 4, they got this product, and they took this beta carbonyl compound and they did the same experiment, heating condition, they got this product. So from that they concluded that this reserpic acid has got this structure, right? I hope now it is clear to you, right? So let me give, so from this reaction, oxidation reaction, they found out that it has got beta carbonyl structure, right? Yes, so they found out that it has got beta carbonyl structure, right? So it has got this structure, sorry, here NH is there, and again here 6-membered ring, both are aromatic, and here OCH3, just I have to add OCH3 because, and here one more nitrogen, right? So they concluded it has got this kind of structure, right? So to give evidence for that condition, so what they did, they took this reserpic acid, that is C22H28N2O5, right? So reserpic acid they took, methanol they added, and they heated it, right? They heated it, so they got this methyl reserpate, right? So you got this methyl reserpate. To this they added selenium and they started heating it, right? Selenium and heated. So this selenium will remove the hydrogen and it will make aromatization. If I have any cyclic compound like this, cyclohexane, if I add the selenium and if I heat, it will make aromatization, right? So they found out that they used to get this structure. Here NH was there, yes, NH, right, and N here, and this nitrogen is there, right? So this nitrogen, this carbon is again expanded like this, and here it is aromatic like this, right? And the structure, the name of this compound was yohimbine, right? Yohimbine, and they saw the molecular formula of this to be C19H16N2, right? 2 nitrogen, right? So to give the evidence for this, they did this reaction and they got aromatic compound, that is yohimbine, and they got its formula, right? So from that they concluded that this reserpic acid has got this kind of structure and there is continuation of chain like this, and this aromatization is happened because of this celium heating. So they concluded like that, right? So further, whether they are getting the same compound or not, that they did in lab by synthesizing it. The same compound they synthesized, right? So how they synthesized, let me give. So they will confirm all the structures by synthesizing them in lab only, right? So now I have to synthesize this compound yohimbine, so that we can tell this reserpic acid has got like this compound or not, right? So what they did, they took this compound. Can you name this? Right, so they took this compound, right, indole, right? So, and to this they added CH2, NH2. So they took this initial starting compound. So the name of this is tryptamine. So tryptamine. They took this tryptamine to this they added this compound, benzene ring, methyl, right, CH2 COCl, right. So this nitrogen with lone pair, it will attack here, electron density goes and come back, chlorine leaves the system, and we will get this product. So product will be like this, benzene ring, nitrogen with hydrogen, right. This nitrogen is basic compared to this, so that will react, other thing remains as it is. So here nitrogen is there, so we will get CO, and here to this carbon it has attached CH2, and here again aromatic ring, and here CH3, which is methyl here. Just if I draw a line like this, it means it is CH3. Further what they did, they heated with POCl3, and they heated. We know that phosphor has more affinity to this oxygen. So this oxygen, it will take one of the chlorine, leaves the system, so this carbon becomes electrophilic. From this it will give the electron density, so ring closing reaction happens, simple ring closing reaction happens, right. So here ring closing has happened, see, ring closing, from here it is CH2 aromatic ring, and here since it has given its electron density, here it will get positive charge, no doubt, and here it has got oxygen, right. So that oxygen is now bonded to phosphor, PO 1Cl and 2Cl, 1 2 3 4 5 bonds are there, right. So this now this is not aromatic, this is anti-aromatic, so aromatization is the driving force. So this electron density, the hydrogen electron density will be here, and it becomes neutral, and H will go out as H plus. So I am not going to write that step, directly I will show that pi bond here, and I will make this neutral, right. So with this there was elimination of H plus and Cl minus, so directly I will write here minus HCl, combining two steps, right. Further what happens, see here it was NH2, right. So here it is NH, right, and here it will be NH. Further I told phosphor oxygen bond will be very strong, so this bond will be broken like this, so this carbon gets positive charge. So to remove that positive charge, this electron density goes here. So what I will get, let me rub the above things so that I can tell you the structure, right. So from this result I got this thing. So cyclization was completed and aromatization was also completed. The only thing is nitrogen here, and here we will get double bond like this, because here positive charge, this NH bond will be broken, that electron density comes here and it becomes neutral, and H will go as minus H plus, right. So it will be simple like this, right. So I wanted this compound, right. So whenever we do this any like dichlorodicyanoquinoline, DCC we add, it will remove these two hydrogens and we will get aromatic compound, that is this thing, right. So this was how they synthesized that. Or we can add DCC also to remove this H plus and H minus two hydrogen, or platinum. Here they added platinum in presence of carbon and they heated, so that it removed two hydrogen and they got this product, that is vibrine they got. So in lab they synthesized this vibrine and they concluded that this Reserpic acid has got this kind of structure, right. I hope it is clear to you from all those reactions, right. And also you should remember how I synthesized this vibrine, the starting material. The starting material was what? My starting material was this thing. All these things you should remember, CH2 and NH2, right. If you remember all these things, then only further we will synthesize this Reserpine. There we will get how we synthesize it. So we will use the same starting material only, because Reserpine also has got this vibrine structure, that you will get it in the upcoming classes. So in next classes let us see the structure of Reserpic acid. From that we will give the structure of Reserpine. Till then, take care and have a great day.